today I'm going to be talking about the main application. My main sort of like expertise is applying machine learning and GeoAI to social good. We've been partnered with a lot of great organization like NASA, World Bank, UNICEF. And today, particularly, I'm just going to talk about 3 use cases because we are going to be feature environmental sustainability, especially in the context of sustainable cities. And while looking at, like how we're applying GeoAI to satellite imagery, street view imagery. We have a lot of other application toward area imagery for wildlife conservation as well. But today, again, right, like it's just like going to be like urban centric work, like we've been doing with our partners. And yeah, so that's it. And Richard did a great introduction of myself, and my name is Zhuangfang Yi. I am a Chinese ethnic minority Thai, born in China and went to school in China and moved to US, and I've been doing geospatial analysis for decades, and like being just like attracted to develop open source tools and machine learning pipeline to help decision makers in international development contexts, like looking at how we can apply machine learning and AI for social goods in a global scale. So that's what I'm gonna be talking about today.
Wonderful. Controls should be your way if you have them.
Awesome. Wow.
So we'll record all the presentations tonight, and then they'll be up within about a day on the website, just the usual one, mki.org.
Awesome. I think you can see my screen now.
We can indeed.
Correct. Awesome. I am going to use this speaker mode. Cool. Let's jump into it. Okay, everyone. Today's title is GeoAI for Social Good from global scale and pandemic perspective. In a couple of weeks, we are going to celebrate our, a year anniversary of COVID lockdown. If you haven't noticed that, I'm pretty sure it's really frustrating. So today is about how we're applying GeoAI to Earth observation data, and all this application is just like going to find more insightful data to support this global scale application of social goods applications. Who is Development C? That's the company I'm working for now. Development C is a small team, like with 46 talents, engineer and developer, rocket scientists, designers. Like we're passionate about advancing the fields in Earth observation, Earth observation science. Our application like leverage massive Earth data, cloud computing, and GeoAI, and sought for development to maximize the information like we can extract from the data to support long-term, lasting impactful decision makings, especially under the rapid changing planet. Currently, we're working with more than 30 partners, like from NASA, European Space Agency, UNICEF, UNDP, USGS, World Bank, and Microsoft. And we've been in the business for 17 years. So talk about the Earth observation and satellite imagery. Our capacity to produce data is in, like a growing, a very fast pace. Hundreds of satellite circle the Earth, sending back a petabyte of data. Using AI and machine learning can allow us to analyze the data at the highest speed. and just like, like put us into a different perspective, like how can we support vulnerable populations and response to nature disaster with the insights from decoding the satellite imageries, and how can we address the response in a 3 or 4 dimension perspective, like how local and international organization can do the work on the ground more efficiently. And can we rethink these above questions from a different perspective, particularly a global pandemic perspective, right? So today I'm going to be talking about 3 applications we've done with our great partners again. First one is GeoAI application under global pandemic. The second one is GeoAI to locate most vulnerable population and housings with World Bank Housing Resilient Program. Third one is putting missing schools on the map of better service delivery with UNICEF. Just jump right into the detail. The first application is GeoAI application or satellite imagery decoding under global pandemic. And here is, just showing you a short video of our screen recording. This is the COVID dashboard we developed for NASA Earth Data team or NASA Impact team. Is a collaborative efforts involving like NASA Earth science data system research and analysis and applying science programs. NASA is one of the biggest Earth satellite provider globally, right? That the satellites, like, of course, like result from like decades of rocket science research behind it, like cover something like nighttime lights that we can track economic activities and urban pulse, that it's monthly and daily products that even can track like electricity outage, right? And satellite to record the air pollutant that can track air pollutions, like satellites has like aperture radar, LiDARs, low and high optical satellite imageries can help us to track like carbon sequestrations in the forest that is critical for climate change. Optical imagery that can help us to monitor the changing planets that, like including some kind of like a long-term mission like Landsat, MODIS, and many, many more, right, like provided by NASA. And what we're trying to do over here is applying high resolution satellite imagery is daily basis provided from another big company, a great company called Planet, through NASA's commercial satellite data acquisition program. That what we're using is use this high resolution satellite imagery, and then just like trying to, okay, I am going to pause this and go to the next slides. To track from car, airplane, and ship in the harbors that, like through the COVID lockdown, like how this parking lot or human mobility has been impacted by the global pandemic. This is the GeoAI applying on satellite scenes that adjacent to Los Angeles International Airports in January. And now you're seeing is satellite capture that car parking lot in July. So COVID lockdown has restricted population mobility at local scale. And, like this mobility is not going to impact the city itself, but it's beyond. When we're talking about like air pollutant, for example, like what you've seen on the right panel, the graph you see on the right side of the dashboard panel is the nitrogen dioxide through the lockdown, right? Like the concentration of the nitrogen dioxide like dropped dramatically to Los Angeles is like as high as 30%, and carbon nitrogen dioxide is just like a short lifespan air pollutant that it acts like a switch, right? Like once the traffic or car like stop moving and the human mobility stopped at the city level, the air pollutant is going to kind of like a turn off and disappear for a short of time, right? Like, but it's not only nitrogen dioxide, other air pollution, air pollutants has a big impact as well. Like we just need to, you know, like sort through. And if you go to, I will provide the link to my slides later, and you can, you know, through the slides, I have a lot of link, like you can go to NASA, like a COVID dashboard that you can start exploring, right? Like my favorite part is the discovery, like has a lot of like short story about like how we use science and you know, satellite imagery track things from like air, lands, climate change, and changing planets. There's a lot to learn. The second cases I am going to talk about is how we apply GeoAI to locate most vulnerable population and houses at the street level. This is work with World Bank. So long before global pandemic outbreak, right? Like, United Nations already have a different sustainable development goal. One of them is making city and urban human settlements inclusive, safe, resilient, and sustainable. So we're going to the facts to understand why the problem is being identified. We need to understand a little bit of like economics behind it, like, you know, why, right? Like often city offer a lot of opportunities as far as jobs and resources to people's family may be in poor rural area looking for making better life. They move to the city searching for higher paid job in the cities, right? And unfortunately, when people get there, they might be pricing out of the formal housing market, end up in a cheaper neighborhood that are often cheaper because the house is not up to code. Building may also be built on the risky lands prone to, you know, nature disaster like flood, landslide, or even on the path of the hurricanes. Under the global pandemic, those are the most vulnerable population, right? They might like don't have running waters, good hygienes, and it's so crowded, like community, and you know, like it's just like not set up for this kind of like a global pandemic when the infectious rate of the disease is so high. So talking about like street view application together with GeoAI, what we can see is, you know, houses look very different, like from culture to culture, from nation to nation, right? That material available to people because the how much money they can spend on, you know, building a house to provide a safer shelter to the family are very different as well. So the size of the windows, doors, a garage, and the pool design actually like put people in danger when the nature disaster comes, like the house can pancake collapse, right? So these to ratify this house is easier, but to find the vulnerable house at the street level is not easy. So, you know, like, again, like people living in this poor building standard are more likely to be affected by the disaster, and government and community are motivated to retrofit those structure for safety. But again, right, like go back to, they can be done, like the factory can be done like cheaper and simple, effectively. But again, to find those house from the street level, it's just like not that easy. And computer vision, GeoAI, and or the machine learning like can help. You know, like so far through this work, we not only implemented the computer vision algorithm in South America, but also like moving to Southeast Asian country. And this work is not only to identify vulnerable houses, that, you know, like we are also keen to applying this kind of like technique to identify like the large windows may not be like, it may be a sign of waste of energy, or building energy efficiency is one thing like we can work toward using the GeoAI and applying on top of the street view imagery, that we can identify the buildings like is very energy efficient or not, right? Like so there's a lot of application like we can be doing over here. And street view imagery is not only like most of us are familiar with Google Street View, but Mapillary, it's open source street view imagery community that provide a lot of like a global street level imagery coverage that can have a potential big impact over here. So it's not only GeoAI can provide insight for houses condition from street level imagery, but by mapping every building footprint from the satellite imagery, that you can sort of like aggregate street level information like we extracted by using GeoAI, but you know, like create some sort of like a joint table with the population census that can be applying to, for example, like which area is informal housing group that have a very populated, vulnerable population that might need immediate help under nature disaster or a global pandemic, or even like COVID-19, like vaccine distribution. That's really critical information, right? So, so far, this work has been applying in Peru, Colombia, Mexico, Indonesia, and more. So we already like went through kind of like nearly like 1 million street view imagery. The third application I want to talk about today is how we use GeoAI or machine learning to put missing school on the map for better service delivery with UNICEF. UNICEF have a very bold initiative to map and connect every school on the earth, to connect kids to the internet, to mitigate educational resources. Again, school is not only the place that kids receive the education, it's also like a community gathering places that it's a shelter after nature disaster. It can become a health center that, you know, where people receive the COVID vaccine, right? Like, or other vaccines, basically. Currently, the school geolocation or data are collected by local officials and also government sectors. Using computer vision is just like one of them. Like is a way we can utilize to map to put the missing school on the map. So just like I'm switching among the definition a lot when I say like machine learning, GeoAI, or computer vision or deep learning. It's in this context, or at least like for this 3 application, I mean the same thing. Under the COVID context or perspective, right? Like kids already, especially kids in like vulnerable community that's not already threatened by this global pandemic, right? And this is going to have like a long-lasting impacts, not only to the kids but also the families. So how can we better like connect them to the internet when schools locking down, and how can we connect schools through like it's just like through the network, like so kids can share the educational resources. School are hard to map, right? Like there's no complete school map existing, right? Like every country, doesn't matter, like US, again, probably like developed countries has a more complete school map, but particularly to global south, school map is not complete. But that's fortunate. That's very lucky, right? Like school actually have the school very distinctive school feature, like can be detected from overhead imagery or satellite imagery, especially high resolution satellite imagery. When I refer to high resolution satellite imagery here is a 50 centimeter, which means any objects like bigger than 50 centimeter like can be detected. Or can be seen by the from the satellite imagery, right? So because the function of the school from the overhead imagery, like you can see through this group of the figure, they have a very unique UOIH shapes. They have like basketball court, playground, swimming pools, and they tend to be a cluster of buildings that have some roof color, roof material, like very distinct. The size of the school are also like bigger than surrounding residential buildings. So luckily, to machine learning or computer vision algorithm, that is some kind of like a feature like we can use to design the algorithm to recognize from the satellite imagery. There's a lot of work going behind it, and machine learning is just like a small part of it. Like to develop a country-specific model, like we've been working with UNICEF, like developing model to specific to East, West Africa, South America, and Asia. That's school. Again, like they look very, very different. So how can we train a machine learning model that is generalized enough? And the GeoAI application is not going to stop when you have a good algorithm, a good model trained. You need to apply those algorithms like to a larger scale, and we are talking about global context here, right? So just imagine like you using a window, like this size of the window, right? Going through your Google satellite imagery, and you're searching for school building that are going to be millions and trillions of windows, like you need to run your algorithm through, right? So there's a lot of like engineering behind it, and we develop a lot of internal tooling to just like helping us to speed up the workflow. One of them I mentioned here is ML enabler that is a tool that we kind of like host on a cloud provider, for example, like AWS. And once we have like a good model, we drop into the ML enabler and, you know, just like pull thousands and millions of the imagery. For instance, like to scan through the whole Kenya, we can do not weeks, now we can do like 12 hours, right? Like Kenya is not a small country. And after that, machine learning is not perfect, of course. So you need a human validation. We have expert mapper like validate the machine learning output and make sure what we're going to put on the map, or when we claim that is missing school, that are the missing school that never been seen or never been mapped before, right? Like to be on the map. So this is the result. The green dot you're seeing is the known school or identified or validated school by us, by UNICEF, by OpenStreetMaps community. And I just want you to pay attention to the yellow color that is machine learning predicted school that never been put on the map, but that already like being validated by the human expert mapper that they are school. So that's how we find the missing school. And blue color is like how well machine learning can actually find the known school, right? Like if there's a more blue color, then that means the model can find like extra school like really well besides finding like missing school. So this is the sixth country. Like I just wanna quickly go through with you that, you know, like how we can map like either nation scale or like global scale school. And those is only like 6 country, and Ghana, Honduras, I'm missing over here. Anyway, so current climate created by COVID-19 outbreak has shown us the importance of universal connectivity. And today I'm here, like, feel really honored to present you the work like I am very proud to contribute to in the past of 3 or 4 years of my career. If you have any question, like you can go as detailed as, you know, like technical. I was the one, I was one of the engineer, like developed the algorithm and design the workflow. And we are here to inspire more idea, especially application of using GeoAI for sustainable city, for social goods, and looking forward to connect with you. And if you have any questions, please just let me know. There's a lot of like social media handle. You can even follow me on GitHub if you want. Yeah, so I will just share this link to the chat of my slides, and you can go through a lot of link I mentioned in the slides. And yeah, that's my talk today.
Thanks, Nana. It was amazing talk, I must say. And to be honest with you, seeing 3 major applications, you know, in the kind of work that you have done, especially when we talk of GeoAI and image satellite, you know, data, it is in petabytes, and we now know that how it can be used for social good, mainly for reaching out to vulnerable population, is the main idea behind it. And definitely, I agree with you how the human behavior has changed during COVID-19 and how you can actually leverage using the environmental factors, compare it to the various results we would have had from the history, you know. And school mapping is mainly the area I think people would be really interested in, how you have helped various people in vulnerable areas for schools, or be it in areas which are prone to disasters. And the point that you made about the vaccine distribution, I think that is of interest mainly to many people. How you are using it for the structure analysis, the street view application which you showed, the images are really interesting. So I think whatever work you have been doing is really mind-blowing. Thank you for doing that awesome work. And there are two questions. If you're okay, I'll just go ahead and ask them. So there's one question from Jitendra, and he has asked as to, how do you label all those data to build the DL model?
Which model, like you're talking about particularly? Do I just like in general talk about?
Yeah, you can talk general to it, or Jitendra, if you want to come in and just quickly put your point, which one are you looking for?
Yeah, actually, it's quite fantastic and fascinating. Actually, it's very impressive. Actually, the way you are actually gathering the data and the way you are working on the petabytes of data. Actually, we just struggle in the 10 images, and you are thinking of billions of images. Yeah, I just had a quick question. Actually, like some of the work you did, like obviously it took a hell lot of time to actually train those models. So is it like available for us, for normal people as well, so who wants to do some, build some application on the top of your model? And some question is like just for a curiosity, actually, how you actually manage to label all those data, actually, how it is possible?
Cool. So there's two questions. One is if you can utilize the ML algorithm or open source data open source workflow we provide. The second one is how we label the data. I am going to, development C is all about open source. So every like AI pipelines or model workflow we develop is open source. Of course, like there's a lot of like hurdle to share code openly. Like we need to be more responsible, like what actually like community can learn from us. And like we are like very small team. We're keen to working on projects like very impactful, as well as thinking from the beginning, like if we are going to open source those things, like who is going to benefit from the workflow and how, right? So if you find me on the GitHub, you can see a lot of like data and code are all available and open source. You can definitely like working from there. And like we are trying to also like do some sort of like capacity building. Like we know that we have experience in GeoAI application to satellite imagery, and we've been in this business for a decade, right? So we accumulate a lot of experience, and we want to share them. So what capacity building is one thing like we're trying to do and do it better. And for the second question, data labeling, very lucky we have like excellent 5 expert mappers. They are not only like like our data analyst, data annotator, but they are a huge contributor to OpenStreetMaps. They validate other people's work. And like so far, small team of expert mapper has been a huge contribution to OpenStreetMaps. If you don't know, OpenStreetMap is another kind of like a huge database that we call map wikis, very similar to Google Street or Google Map, but it's like open source that like every map objects available through OpenStreetMap that you can extract it from, right? So yeah, we're just very lucky to have a team of expert mapper to work alongside with machine learning engineer, like who can quickly not only like label the data, but they can create the toolings that speed up the data annotation work for producing a high quality training data sets.
Okay, thank you very much. Actually, it was really impressive, actually. And then I will try to connect you in the GitHub as well. Thank you.
Yeah, totally, please.
So there's one more question from Farida, and she said, do you do any ground truthing with the AI models?
I am, do you want to elaborate a little bit more ground truthing? I'm not sure if it's equivalent to human validation after the AI, but yeah, if you want to jump in to quickly explain that, I will.
Yeah, I think Farida, if you want to add any details, or otherwise, yeah.
Thank you, Yi. Thanks, Giselle. I think she mentioned something about it. She said they have people on the ground who actually go ahead and verify for them that these are actually what are the same elements that they see on the ground. So I think she answered it. Thank you for the great work. It's really interesting. Thanks.
Thank you.
And on the grounds of that itself, Nana, we also have a similar question from Puyu Ling that did you do any validation of your result?
Yes, everything we put on the map, like we are going to be responsible for the results. So human in the loop, that's one concept we applying, and validation is very important. And now we are trying to go to the direction of like how to have like human and AI collaborated better together. For example, right, like after human validation, like how can we loop all the training data set, high quality training data set back to the AI that model can learn better. So, you know, speed out better result. So more and more is going to require less human intervention in the future. So that is one of the direction we're trying to go. Yeah, so human validation, yes, of course.
Yeah, and there's one last question I'll go in for at the moment. It's from Andy. How does this sort of collaboration with NASA, World Bank, etc., get off the ground as they are so critical? Do you approach those organizations?
Do you mean like how this impact is going to last on the ground? I think, you know, like, again, as the kind of like data analyst company, or who is the brain behind this kind of like algorithm, this is actually I see this as the value chain, right? Like we are actually sitting in the middle stream of the value chain. That downstream is people who actually make impactful work on the ground in the nation or at the local level. And what we provide is we're trying to be very responsible, the data that we feed it into the hands of the local official, right? We need to make sure that it's high quality, it's reliable, and that's how the downstream data or impactor like coming back to fund us. So that is one way to looking at it. And another way is just like trying to have a designer brain or perspective that how those people, like put ourselves in the shoes of how those people are gonna utilize the data. Like how can we build actually not only like, you know, like throwing the data to people, but actually like packaging them in the way that makes sense for people to actually see the data and also inspired by utilize the data. So part of work is, you know, like we do a lot of like visualization, platform building, like actually helping people to interact with the data, right? And upstream, right, like we working with NASA and European Space Agency is like archive all this Earth observation data on the cloud. So us or other people like can access the Earth observation data, satellite imagery, like easily. So this is also like the impact itself that, you know, once people can access data easily, they can extract the insights from the data and have a long-lasting impacts along this value chain. Yeah, so that's how I see it.
Thank you, Nana. I think this is where I would leave you with the chat. You have received amazing comments for your incredible presentation. I'm sure people are going to really find some applications to work on, especially with your GitHub link, you know. And now I would hand over to Richard to move on to the next speaker. Thank you so much.